In this video, we're going to look at more applications of geometric series. The question here is to find the sum of the following geometric series if the series converges. So we have summation, k goes from 2 to infinity, 3 to the power of k times 2 to the power of 2 minus 2k. Our goal is to write this into the pattern summation, k goes from 1 to infinity. This is the infinite geometric series pattern, a times r to the k minus 1, where a is the first term and r is the common ratio. So we have summation, k goes from 2 to infinity, 3 to the k. We can write this part as, we can put that into the denominator and just multiply the exponent by -1. So we get 2 to the power of 2k minus 2. So we get summation, k goes from 2 to infinity, 3 to the k, divided by, now 2 to the power of 2k, we can write this as 4 to the k, and we have 2 to the minus 2, that's 1/4, so the 4 ends up in the numerator. So we now almost have the pattern that we need. K goes from 2 to infinity, 4 times 3 over 4 to the power of k. But we need this index k, so we need the index k, the starting index. We need the index to start at k equals 1. So how do we achieve that? Well, we can subtract 1 from the index k and add 1 to the exponent to compensate. So we get summation, k is equal to, subtract 1, we get 1 to infinity, 4 times 3/4 to the power of k plus 1. We still don't have the pattern that we need, we just need to do a bit more algebra to achieve that. Alright, so we have summation, k goes from 1 to infinity, 4 times 3/4 to the power of k plus 1. The pattern that we need for the infinite geometric series is summation k goes from 1 to infinity, a times r to the k minus 1. So we have summation, k goes from 1 to infinity, 4 times, let's factor out 3/4 squared, so we have 3 over 4 all squared, times 3 over 4 to the power of k minus 1. So we factored out 3 over 4 squared. Now if we simplify this, we get k goes from 1 to infinity. Well, here we have 4 times 9 over 16. That simplifies to 9 divided by 4. 9 divided by 4. Multiplied by 3 over 4 to the power of k minus 1. The advantage of getting it into this form is now we have the pattern of a geometric series where this part is simply a, and we have the common ratio r raised to the power of k minus 1. Alright, so this is a geometric series. Let's write it out. This is a geometric series with the starting term, a is equal to 9 over 4, and the common ratio, r is equal to 3 over 4. And since r equals 3 over 4, the common ratio is magnitude is less than 1, this geometric series converges with the sum s is equal to a divided by 1 minus r. So s is equal to, a is 9/4, that's the first term, divided by 1 minus the common ratio, which is 3/4. This gives us 9 over 4 in the numerator, and 1/4, if we subtract 3/4 from 1, 1/4 in the denominator. Simplify this, we get 9 over 4 divided by 1 over 4, that gives us 9. So we say summation, k goes from 2 to infinity, this infinite geometric series, 3 to the k, times 2 to the 2 minus 2k. We did some algebra, and we changed the pattern to summation k goes from 1 to infinity, 9 over 4, times 3 over 4, to the power of k minus 1. This infinite geometric series converges to a sum of 9. The sum is 9. All right, let's look at another example. Here we have expressed the number 5.213, where the 1, 3 repeats itself, as a ratio of integers by applying geometric series. So let's expand out this repeating decimal. So we have 5.213, 1, 3, 1, 3, and the 1, 3 just repeats. This is equal to 5.2 plus 13 divided by 10 cubed, that's 1,000, plus 13 divided by 10 to the 5, plus 13 divided by 10 to the 7, plus ... Now, after the first term, so after the first term, which is 5.2, we have a geometric series. So the geometric series starts at the first term of 13 over 10 cubed. 5.2 is not part of the geometric series. So after the first term 5.2, we have a geometric series starting, and the first term of the geometric series starting with a is equal to 13 divided by 1,000, which is 10 cubed, and r, which is equal to, well, r is going to be 1 over 100. We're going to show that. So to find the common ratio r, basically we have the ratio of successive terms. So 13 divided by 10 to the 5 divided by 13 divided by 10 cubed. And if we simplify this, we're going to get 13 cancels with 13. We get 10 cubed divided by 10 to the 5. 10 cubed divided by doing a bit of algebra. This gives us 1 over 100, or 1 over 10 squared. All right, so we can write 5.213, this repeating decimal, as 5.2 plus the sum of a geometric series. Now notice that the common ratio r equals 1 over 100 is less than 1. For this reason, the series converges, the geometric series converges. So we can apply the formula S is equal to a over 1 minus r. So a is 13 over 1,000, all divided by 1 minus r, 1 minus 1 over 100. And we get 13 over 1,000. So this is equal to 5.2 plus 13 over 1,000 divided by 99 over 100, if we subtract 1 over 100 from 1. So if we simplify this, we're going to get, so we have 5.213 repeating. This is equal to 5.2 plus 13 divided by 990. Let's make sure that's correct. So we have 5.2 plus 13 divided by 1,000 times 100 over 99. So we get 13 divided by 100 cancels with 1,000 gives us 10, and 10 times 99, that's 990. That's how we get 13 over 990. All right, so 5.2, we can write this as a fraction as 52 divided by 10, so we can add up these two fractions. Plus 13 divided by 990. Take common denominator, which is 990. 10 goes into 990 99 times, so we get 99. times 52 plus, and 990 goes into 990 one time, plus 13. This is equal to 5161 divided by 990. So what we have basically is this repeating decimal, 5.2131313 repeating, and we have applied geometric series to write this as a fraction, a ratio of two integers, 5161 divided by 990. So just to expand on that, we have 5.2, 13, 13, 13 repeating. This is equal to, we write this as 5.2 plus 13 divided by 10 cubed plus 13 divided by 10 to the 5 plus 13 divided by 10 to the 7 and all the way, dot, dot, dot. This is equal to 5161 divided by 990. Now 5.2 is not part of the geometric series. The geometric series starts with the first term, which is a is equal to 13 over 10 cubed, and so we have this geometric series starting with a is equal to 13 divided by 10 cubed, which is 1,000, and r, the common ratio, which is going to be 1 over 100. And because r, absolute value of r, is less than 1, the infinite geometric series converges to a finite sum, and we're able to apply geometric series to express this repeating decimal expansion as a fraction. And that fraction is 5161 divided by 990. All right, thanks.